where to get started. And first of all, that question, and number two is, I hope that all of you are doing well with your labs. I know most of you haven't started yet, but my suggestion is, given the fact that we have one more week right here before we go for 2 weeks holiday, you try to do it and finish it before you go for the holidays, actually. So that will be helpful. Of course, you'll be having enough time after you come back from the holidays, probably one more week. Not exactly, because the deadline is 8.
Do I have to capture on the window?
You have to show us the step by step. And to show in the end, very much. Is that clear? The information that will later help you to remember that what did you do right there. Okay. Or another way of doing it is open your Word file, start lab 1, write whatever instructions or whatever introductions you want to put. Then start installation. As you move to each new window during the installation process, you capture and paste it on Word file. Add one or two lines. Sorry about it. My browser crashed. The browser crashed. Let me write it down once more. So as I said, ideally you should keep a Word file open and then start your installation. And for each screen that you pass through, you just take a quick screenshot and paste it on the Word file and add a couple of lines of notes, and then come back and move to the next screen for installation, capture it, and do the same. You don't have to go through all of them, but at least 10 or 12, I do expect. Okay, so this should be the ideal method. For those who haven't started it, please remember that. That way you don't have to store the images and you don't again have to go back, because if you store all the images, you will get confused which one came first and which one came second, isn't it? So think in a logical way, you will see the thing that I mentioned is much easier. And then don't forget to convert all the files into PDF format. Otherwise, you will lose 20%. Is that okay now? Hope so. The one thing that you'll have to, all right. Okay. So keep your Word file open. And then for all the labs, keep the file ready. This is lab 1, this is lab 2. Also the lab 2, also the lab 3, the same. And then you do something on your VMware, Fedora, whether it's installation, whether it's running some shell scripts, whatever. And for each input output screen or for each new screen, you just simply press Shift and print screen, and then go to your Microsoft Word, and in the right place, you paste it. That's it. And then you adjust a little bit your photo and put it in the shape, and those things you can do later. Because otherwise, you will feel absolutely confused if you take the pictures and store them in a folder. Because later, you will never know which one came first and which one came next. Okay, so think logically. If you do it in a logical way, see, it's fun. It won't take much time. As I said, hardly 24 hours to finish all the labs, all the labs. So on a good day, when you're free just before the vacation starts, just before the new year comes, why don't you just go ahead and finish it off? So you don't have to bother about it and worry about it. You can focus on the subject because that is important. All right. So now you have to remind me where we were. So browser crashed, man. That's a problem. Oh, sometimes it keeps crashing. All right, there we are. Did we finish process? Let me share the screen with you. We have to complete 4 labs before 8 February, right? Yes, 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 yes. As I said, eh, less than 24 hours. Less than 24 hours. In fact, if install the software successfully and finish other labs in next 2 hours. Done. It won't be taking more than 2 hours to finish the other labs. Very simple task. So first, read the instructions and know your job, know your task. What exactly you are required to do. Once it's clear in your mind, then you sit down just for 2 hours or 3 hours. Well, of course, the installation may take a little bit of time, so maybe you install it the first day, and the next day you open it, spend 2 more hours to finish all the labs, and then put them together in one folder, zip it up, and submit. Oh, don't forget PDF. Now you have to tell me where we were. I remember we finished process, right? But we didn't start thread. Should we start thread today? Where to get started? Process implementation of process. Okay, good. So let me stop this one and go back and get started. All right. So there we are. We will move down to implementation. There we are. So already know quite a lot about the processes, and we take a closer look at how processes are implemented. So when it comes to implementation, that means how the processes are executed. We understand, of course, there's a difference between execution and implementation. Because when we use the first word execution, we usually refer to CPU. So now CPU executes this. Is the one that will execute the instructions in a process. So it executes a process. But when it comes to implementation, that means someone who has an absolute control, and control implementation is all about the control. Control on what? Control on process behavior, and that is OS, or the operating system, or in fact, the kernel inside the OS. So the kernel maintains a process table, and inside the process table, we have a PCB. Now, as I mentioned, that if you look at your task manager, that is essentially the PT, and it has been picked up and on demand and displayed to you through a special window, and is given a fancy name, Task Manager. There's only one task that you can do there is to kill a process. Inside your PT, you have multiple rows and multiple columns. So from each row represents a process, P1, P2. Remember, that means something or a process or a program which is currently loaded on RAM. Not necessarily running at the very moment, but could be blocked, could be in the ready queue, but still they're all on RAM. So they will show up in your PT or process table. They must show up right there. So we have a process table. And inside the process table, we have a PCB, process control block. What is this process control block? We call it process control block because in the subsequent cells next to each of these processes, some vital information about each of these processes have been stored. Now, these values are all connected or coming there from the n number of registers inside CPU. Everything is stored right there. It's a whole bunch of information. As you can see, the process ID, state, value of the CPU register, and blah, 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 blah. Finally, dot, dot, dot. Because all these important values must be loaded on CPU register, CPU's memory unit, or the registers during the execution time. And when it's not executing, these values are stored right here inside the PCB. So these PCB values that you see, the process control block, the reason we say control, we use the word control, is because these are the information that OS needs to know about a process to control it in a more efficient way. Clear? So we have the PCB and the control, the process control block. And this is vital. This is very, very important. Because if the kernel doesn't know anything about process, it will not be able to control it properly. It will not be able to implement it. So when it comes to implementation of process, there's only one choice, kernel and operating system. So operating system, or rather the kernel of the operating system, which is quite different from what we'll find later when we go to see the thread implementation. Okay. So we'll talk about it later when we go there. Now, since all these PCB values are connected to the runtime registers inside your CPU, so next time you go to Task Manager, don't do anything, just keep it open and keep an eye on that. And you will see in real time these values are changing, updating, tick tock, right here, and then this one, this one, this one, that one. They're not constant. They are constantly being updated. Okay. Because as I said, these are connected to your CPU register. So we understand the process implementation. So when it comes to the actual implementation, as we mentioned before, that we need switching because the multi-programming computers work on the fundamental idea of switching. Just a moment. Okay. So what is this? Is the switch time, CPU switch. And this is, as we say, the pure overhead or latency time. Remember, elsewhere we use the word overhead. That means the CPU is running, but it's not doing anything. It's kind of idle. It's still consuming the power to keep running, but it's not giving any output. Simply because during this switching time, a whole bunch of things are taking place, which essentially comes down to two things. Save the state into PCB 0 and reload the state from PCB 1. Okay? So that's why I said that when you look at your task manager to any particular process and you see those values changing in real time, so maybe because they are currently running, that process is currently running on CPU. Its register values are changing and in real time they are getting updated. So we must save the state into PCB in the outgoing processes PCB. Say, for example, this was PCB 0, this was PCB 0, sorry, this was process 0, and this is process 1. So process 1 is the new process that is about to start execution. Okay, so this one, process 1 executing, this one was process 0 executing, and now process 0 wants to come back. Okay, so what will it do? Again, it has to go through that idle time. This particular time is the context switching time, which is called the latency time because your CPU is latent and is considered a pure overhead. Okay, this is important and interesting. Degree of multi-programming. It's all about CPU utilization, a very important thing. CPU utilization. We want, remember, CPU is a vital resource. And when you, just like anything else, that you want to get a vital resource, you want to acquire a resource, you want to use it as best as you can, right? To its maximum capacity. You want to get the best out of it and the maximum out of it. But that is what we call utilization. Because remember, there are two words. As you see, utilization and usage. They're a little bit different in meaning. If you understand the meaning, the difference in meaning, then you can easily understand why we call it utilization. We never said CPU usage. Yes, CPU usage is something that also is also measured and analyzed, and kernel keeps an eye on that. But the most important thing that we're going to talk about here is CPU utilization. So to understand this concept, I'll rather give you a simple analogy. And this simple analogy, hopefully, will help you to understand why we need SIP utilization, what we mean by the word utilization, and how we can increase the utilization, improve the utilization. And that is our target because the optimum CPU utilization, the best performing computer is around 90%. Okay? So, what exactly it is? Think about this analogy that you go to the market and you buy an apple and you spend $10 for it. So I may actually ask you that why did you spend so much money on this apple? $10. What will you say? Why did you spend $10 to buy an apple? Well, quite a big apple. Because depending on its size and the country of origin and some other specific details like organic, okay, or non-organic, and a particular brand probably associated with the apple, you in your mind you have estimated the total nutrition the worth of the total nutritional value of this apple to be more than equals to $10. Think about it. I repeat, given certain factors related to this beautiful apple, in your mind, you have estimated the value of this apple. That means the total nutritional value that you'll be getting after consuming this apple to be more than or equals to $10. That's why you spent $10 to buy this apple. You could even buy an apple for $1, but you didn't do it. You didn't go for it. And in fact, this is exactly what we are doing all the time when we go to the market to buy something. Sometimes, if someone asks $10 for an apple, you'll just go crazy. You say, $10 for one single apple? No way. It can't be that expensive. But sometimes you will happily pay the money. Why this difference in attitude? It's all because in our mind we have an estimation. And the estimation of the net worth of the total nutritional value of the apple, in this case, is $10. So that's the first part of the story. So your parents paid $10. So now what we are interested in is the total nutritional value. Say if you pay $10, then you get 100% nutritional value or 100% of its nutritional value. Now back to our point. Now you bring the apple back home and you start eating it. But unfortunately, this apple is just too big. So you ate half of it and threw the other half because you couldn't finish it, threw it out in the rubbish bin. Okay? That is scenario one. In this scenario, under these circumstances, if I ask you this question, how much of these apple you actually used? I use the word used to put it in our context, cheap utilization. You can say 8. How much of these apple you actually ate or you actually used? Well, the answer is 50% because you ate half of it. Now, if I rephrase this sentence in a slightly different way and say, listen carefully, if I say, How much of these apples' total nutritional value was utilized? How much of these apples' total nutritional value was utilized? Then your answer is still 50%, isn't it? Because you ate half of it. Now I change the scenario. You brought the apple home, you ate half of it, as usual, because it's too big. But the other half, rather than throwing it into a dustbin, in a rubbish bin, you share it with two of your friends who finished it up. In this new scenario, if I ask you the same two old questions, if I ask you how much of this apple you actually used, you actually ate, your answer is still 50% because you ate half of it. But now, when I go to the next question and I ask you that how much of these apples' total nutritional value has been utilized, the answer is 100%. Nothing wasted. Easy, right? Like a kid story. But so can anyone tell me what is the difference between these two key words, usage and utilized? Let me see. What is the key difference? Even if you have followed my example, and probably from my example itself, it is pretty obvious what the difference is. So, what is the difference between these two words, usage and utilization? I think I say conceptually or logically. What do you think that makes these two words different? Anyone would like to volunteer? Please answer on the mic because I can't see my chat box. It's pretty obvious. The answer is pretty obvious. When you use the word usage, you are looking at the whole scenario from a user point of view. Think about it. On the other hand, when you use the word utilization, you are looking at the same scenario from the resource point of view, isn't it? That's it. That's what became so important in our computers, inside our computers, because we have to look from the resource point of view. Here, in this case, in this story, the resource is the apple. Only then we can use the word utilization. So hopefully, all of you, you have understood this simple, little bit childish analogy. It's not childish at all. It's important. Why? They have given us a simple equation to do the calculation, to calculate it. And I advise all of you to remember it because you just never know. It's so easy. So just here and there, they might ask you some questions. CPU utilization, and they might ask you to do it in the exam. What is P? Is the time waiting for IO to complete, and N is the number of processes loaded on RAM. Right? If you take an example for that
A computer has 512 MB of memory, with OS taking 128 MB, and each user program also taking up 128 MB with an 80% average I/O weight. Then, if you put them in the equation, you get a meager amount of utilization, and that is 40%, 49%. Not good. CPU is underutilized. Underutilized. Now that you get this 40%, 49%, so let's see how we can improve it at another 512 MB of RAM. And miraculously, CPU utilization jumps to 79%, doubles up. Less than double, but almost there. 80% CPU utilization. So, what is the reason behind it? Why increasing? Can anyone tell me? I really want to hear from some of you. Now, why? Of course, mathematically, we can see that this is true. But in theory, how will you justify it? Why do you think increasing the RAM which should increase the CPU utilization? How will you justify this equation theoretically or in theory? What do you think? Anyone? Why increasing the RAM should increase the CPU utilization? No one. What do you think? Let's see. Okay. No one. Why? How will you justify it? Well, remember this story I told you. How can you increase the utilization of a resource? We can increase the utilization resource by sharing it. Sharing it among others. That's exactly what you can do now with 512 MB of extra RAM. Extra RAM space, that means more processors loaded on RAM side by side. That means more mouths to feed. More mouths to feed, literally. So that means now your uh, CPU can be shared between multiple processes and more processes. And that will increase the overall CPU utilization. If you have limited RAM, limited space, limited number of processes can be loaded. If you have more RAM, more processes on RAM, that means more mouths to feed and more processes to share the CPU with. This is a very important analysis which is done inside the computer all the time, and CPU does have OS does it, and OS keeps an eye on the CPU utilization of each of these each of these processes. Is that clear? So that brings us, if you have any question from this part, feel free to ask me. To the next part, that is thread. Any question from this part so far? Okay, before we get started, the threads right in the middle, we want to finish the other job. Wait a minute, because the last class my computer crashed. Oh, and this class the computer crashed. I'd like to take your attendance right now. As I said, I will take it at random times. All right, a quick one. Chi Bao,
Yes.
Yuan Min, Wang Koi,
Yes, teacher.
Tui Chang,
Yes, teacher.
Van Dung,
Yes, teacher.
Yan Huang,
Yes.
and Dui,
Yes.
Tong Kwa,
Yes.
Tian Lok,
Yes.
Tan Chuan,
Yes.
Tian Fat, Tian Fat, Nop Viet, Wing Chiu,
Yes.
Nep Min,
Yes. Yes.
Chuan Kiet,
Yes.
An Thi,
Yes.
Yu Chong,
Yes.
Hu Phúc,
Yes.
Hu Duc,
Yes.
Min Chien,
Yes.
Wang Lin,
Yes.
Tan Nhan, Wang Tai,
Yes.
Chiang Kuei,
Yes.
Jia Kim,
Yes.
Hu Yu,
Yes.
Jung Tu, and Vo Wing.
Yes.
Hey teacher, faculty present.
Which one? You send me an email, send me a message.
Uh,
Already sent, not yet. Okay. Anyone else? Other than not yet? Okay. That is final. Those will come after this. They should know the attendance has already been taken. Good. That's a good strategy. It's the best I can think of. Taking attendance at random times. Now, threads. I see. See. Okay. The answer that you can get if the processor is not too strong. The answer to that is, give me a minute, let me update. Okay. Back to where we were. The question is, yes. And it is not about strong. It's about the peculiar connection. It's about, not the peculiar, it's about the connection between